just have one volume loud.
Just text me if you figure it out. Bye.
Okay, so homework was due last night. Your test closes today, and only 6 people have taken the test, and your average is an 84 of those 6 that have taken it. Good news is everybody has passed with either an A, B, or a C. So far, so good. Okay. Bad news, we are finishing up chapter 7 and 8 on Tuesday, which means you'll have another test next week. Next week. Yeah. I know. Time flies when we're having fun. But there were only 4 sections in 7 and 8. We had 2 sections in 7 and 2 sections in 8. So there's not that much material for the 7 and 8 test. So we've already done 7-1. We've done half of 7-2. So today we will finish up chapter 7 and start chapter 8. So that means Monday we'll finish up chapter 8. So by the end of class today, we will decide when you want your test to start and end, and when you want your homework to be due for 7 and 8. And then all we have left is 9 and 10, and remember you do not have a test for 9 and 10, you just have homework. So after today, your 5 and 6 homework is done. After today, your 5 and 6 test will be done. And then all you will have left is 7 and 8 homework, which is 4 sections, 7 and 8 test, which is 20 questions, 9 and 10 homework, and your final exam. So that'll be the rest of the semester. And we only have 3 weeks left. So that kind of lets you know what's coming up. As a brief reminder of what we did last time. If I gave you a problem where I told you the mean and I told you the standard deviation and I said what is the probability or what is the percentage, we used in normal CDF. We did the left shading or where the shade begins. We did the right shading or where the shade ends. Then we did the mean and the standard deviation. If I told you to find the z, so either we were finding the probability or we were finding the z. If I told you to find the z, you were going to use inverse norm. And for inverse norm, you always do the area to the left, just like Beyonce, to the left, to the left. So area to the left means standard deviation. So for the first one, what is going to be my left shade? Where did I start shading on the left? Where did my shade begin? Negative 99999, because it's going towards negative infinity. Where did my shade end? It would help if I would have told you, wouldn't it? 85. What is my mean? 100, and my standard deviation is 18. And we're going to do the normal CDF because we're trying to find the shade. It is normal to throw some shade. It's normal when we're trying to find the shade. Now, for this one, we're doing inverse norm because we're trying to find the z. So, for this one, we have to know the area to the left. They did not give me the area to the left, and the area to the left is what I need to know. So, if this is 20%, what is this going to be? 80%. So my shade to the left is going to be 80%. So 0.80 or 0.8 is going to be my shade to the left. What is my mean? 50, and what is my standard deviation? And we're doing inverse norm because we're trying to find the z. We spent a lot of time doing this last time. Which one is it going to be? It's normal if you're trying to find the shade. It's inverse if you're trying to find the z. And we're going to build on to this today. But I do have, I think, 5 more pages of problems like this just to make sure we know it before we build on. Now, this is still 7.2. Let me put that up here. We're still doing 7.2. They do a different little terminology, but it means the same thing. We are doing Z sub alpha. You can kind of see how it's written. It's Z with a sub, 0.02. And this is telling you that the value of alpha means the shade to the right. So Z sub alpha is, let me write it for you.
It's still 7 point.
7 point, am I in 2 or 1? I'm in 2. 7.2, section 7.2. We started 7.2 last time, but we didn't finish it up. So it says anytime you're doing Z sub alpha, that means you're shading to the right. Shading to the right when it's Z sub alpha. So if I were to draw this, they did not give me a mean and a standard deviation. So if I do not know a mean and a standard deviation, do we remember what the mean and standard deviation are? 0 and 1. Now, the point, hold on, let me find my little area, my section where I am. Because this means shading to the right, that is telling me that 0.02 is my shade to the right. So 0.02, your alpha is always your shade to the right. Now, am I going to do a norm or am I going to do an inverse norm, and why? I'm not going to do a norm because norm is to find the shade. This is giving me the shade. I know the standard deviation, I know the mean, and I know the shade. So I'm going to be doing the inverse norm. So I'm going to do inverse norm. We're going to do shade to the left, mean, and standard deviation. So what is my shade to the left going to be? 0.98. 0 and 1. So as long as you know what that terminology is, it's exactly what you've been doing. So if this is 2 cents or 2%, this is going to be 98%. It's always your shade to the left when you're doing inverse norm. So when I go to my calculator, I'm going to do second bars. I'm going to go all the way down to inverse norm. No, I'm not. Where am I going?
It's 3.
Oh, it's going like way down. I don't know what I was thinking. 0.98, 0, 1. So what does that tell me? What does that 2.05 tell me? What are we trying to find when we do inverse norm?
The Z-score.
The Z-score. So that tells me it's positive, which means it's on this side. So that's telling me that my Z-score is going to be a little over 2 jumps to the right of the mean, which makes sense. And let me come down so that I can kind of show you the prettier version. And then I can come right here. So that's telling me that my Z-score is 2.05, which is where that is. Cool? All right, let's look at another one. This is how they're going to look on your homework. They're going to be like wordy, ugly. Assume that a random variable x has a normal distribution with a mean of 50 and a standard deviation of 7. Compute the following probabilities. So what are they wanting us to find? Compute the following probabilities. The shade, the probability, the percent is under the shade. Compute the following probabilities. Be sure to draw a normal curve with the area corresponding to the probability. And right here they're even saying the area that corresponds to the probability shaded. We're trying to find the shade, so what are we gonna be using? Normal. Okay, so, let's draw this one. A normal distribution with a mean of 50, a standard deviation of 7, and I want my shaded area, my X, to be less than or equal to 58. Alright, so we have a normal distribution with a mean of 50, a standard deviation of 7, my data point is 58, and I am shading less than or equal to 58. So we're trying to find the shade. So because we're trying to find the shade, that means we're going to do a normal. So normal CDF, where does the shade begin? Negative 9999. Where does the shade end? 58. What is my mean? 50. And what is my standard deviation? 7. So it's where shade begins, shade ends, mean, and standard deviation. So when I go to my calculator, okay, this is where my shade begins, my shade ends, my mean, and my standard deviation. When we type that in our calculator, that tells me that 87% of my graph is shaded. 87.35% of my graph is shaded. Coming back from last time? Stop me if you don't get it. This is where it begins. This is where it ends, or this is on the left, this is on the right. This is my mean, this is my standard deviation. Cool?
Where'd you get normal CDF when you calculated?
Second bars. Second bars.
And okay, I see.
Yeah, normal CDF, and then like the third one is inverse norm. Those are the two that we're using right now. Cool? All right. We are using the same mean and the same standard deviation. Our mean is 50, our standard deviation is 7, and we are trying to find the probability. Which means we're trying to find the shade. The mean is 50, the standard deviation is 7. We are trying to find the probability. No? Good. Just okay. Let's call it today. Good. You did. It's amazing when it starts clicking. So for this one, we have a mean of 50, a standard deviation of 7, And our two data points are 56 and 68. The reason I knew that I was going to the left of both of them is because both of my data points are above 50. So if my mean is 50, 56 and 68 are both to the left of 50. And I want to shade between those. So I'm shading here. Because I'm trying to find the shade, I'm going to do normal. So the normal CDF, where did my shade begin? Where did I start shading on the left? 56. Where did I stop shading on the right? 68. My mean is 50 and my standard deviation is 7. So your answer should have been that 19% of that graph is shaded, 19.06 or 0.1906. Cool? And we're going to be doing the same kind of thing in the next section. It's just going to be getting a little bit harder. That's why I want to make sure you understand it. Assume that the random variable x is normally distributed with a mean of 50 and a standard deviation of 7. Find the indicated percentile. Now remember we talked about percentile and I told you that Madison was in like the 97th percentile for height. That meant that 97% of the population was below her. So percentile means to the left. When we were doing Z alpha, that meant to the right. Percentile means to the left. So 90 percentile means that 90% is, or 0.9 is the shade to the left. Okay, so if I'm drawing this, it is telling me that we have a normal distribution with a mean of 50 and a standard deviation of 7. Percentile, that means the shading. So that means that 90% is shaded to the left. So that is going to be 0.90. So what do you think we're trying to find in this problem? We're trying to find the z-score because we were already given the percent shaded. So we're trying to find the z-score. So what are we going to do in this problem? Inverse norm. So when you're doing inverse norm, it's always the area to the left, comma, the mean, comma, the standard deviation. So what is my area to the left? 0.9. My mean is 50, and my standard deviation is 7. So anytime you're given these problems, you've got to figure out what is it telling me. This time it was telling me the percent under the curve, which means I have to be finding the z-score. Last time it was telling me the z-score, so I had to be finding the percent under the curve. So the problem is going to lead you into what you're trying to find. Cool? All right. Just take A for this problem. Give me just a second. I think I didn't get rid of. Hold on. Delete. Delete. I just want A up here. Because I think I did B, C, D. I didn't get rid of A. easier the more that you do them, so I'm gonna give you another one to practice. You have an 18-ounce bag of Chips Ahoy chocolate chip cookies that is normally distributed with a mean of 1262, a standard deviation of 118. What is the probability that a randomly selected 18-ounce bag of chocolate chip cookies contains between 1,000 and 1,400 chocolate chips inclusively? For every problem, even when I do them, I'm going to draw me a picture. And the hardest part is setting them up. Typing in the calculator is nothing. So we just want to make sure we can set them up. Travis came in, Josh did not come in, and Sharon did not come in. All right, we have a normal distribution. Our mean is 1262. Our standard deviation is 118. What is the probability? So what are we trying to find? Shade. If it says what is the percent or what is the probability, that means we're trying to find shade. Which means we're going to be doing what kind of problem? A normal. Now, our data points are 1,000 and 1,400. So we're going from 1,000 to 1,400. That's where our shade is going to lie. So, when we do normal CDF, where does our shade begin? 1,000, where does our shade end? And then mean and standard deviation. Yay? All right, we're going to be using those same directions. So for all of these problems that we're getting ready to do, the mean is 1262 and the standard deviation is 118. And then there's the answer for those that, oops, it's going slow for me. This is the answer for those of you who did it in your calculator. Fewer than 1,000. Fewer than 1,000. 1262 and 118. This time is fewer than 1,000. What is the probability that it's fewer than 1,000? So because we're doing probability again, that means we're finding shade. Fewer than 1,000. Fewer than 1,000. We're finding the shade, which means we're going to do what? Normal. Where does the shade begin? Negative 9999. Where does it end? 1,000. What is my mean? And my standard deviation?
I would argue it begins at 0.
For this one, yes.
Because
Because you can't have a negative infinity. Love you, Barrett.
you could never have less than 0 cookies in a bag.
I love you. For the purpose of this, They said negative 999, but he is correct, you can never have less than 0 cookies. But because it's a normal distribution, they're saying that it's going to tail off to infinity. But yes, you are correct, you can never have less than 0 cookies. I love smart thinkers.
It's the same answer.
Yeah.
Same answer?
Rounded to 4 decimal places, it's the
Same answer.
Even rounding out to like 10 decimal places.
It's gonna be the same.
Calculator's the same.
I love y'all. Contains more than, and these are all the same, so I'm just going to, this one is 1262 with 118. This time it says what proportion? Proportion, probability, percent. It's still going to be find the shade. So if it says proportion, if it says probability, if it says percent, y'all know that mathematicians are paid lots of money to confuse you. This time we are doing more than 1200. 1200 is going to be here. And y'all, if this was a test, you know your final exam is multiple choice. So if this was a question on the final exam, if this is 1262 and I said more than 1200, you know your percent is going to be higher than 50%. You with me? So we can mark out, just by drawing the picture, we can mark out any percentages that are less than 50. So, because we are trying to find the shade, we're going to do the normal. Where does it begin? 1200. Where does it end? Who? Positive 9999. And my mean and my standard deviation. So, 1200 to positive, my mean and my standard deviation, so it's about 70% is shaded. Okay, here's one that says fewer than 1125. So it is 1262, 118. This one's going to be 1125, and because it says fewer, we're going to go this way. It is proportion. Proportion is another name for shade. So again, we're going to be doing norm. Where did we start shading? Where do we start shading? Negative 9999. We ended at 1125, and our mean is 1262, and our standard deviation is 118. I'm going to move this up so I can have it in the same. I don't know why I put that one so far down. Let me move this up so I can have them together so you can see them. So that is saying that 12% or 12.28% is shaded below 1125. What is the percentile rank of an 18-ounce bag of Chips Ahoy that contains 1475 chocolate chips? What is the percentile rank? What did I tell you that percentile rank meant? The probability, the shading. So we have the 1262 and we have the 118. Now, was percentile rank to the left or was percentile rank to the right?
Right.
Left, to the left, to the right. Which one was it?
The right.
If I said my child was in the 97th percentile, does that mean 97 people are above her or 97% are below her? Percentile is the amount of people that are below her. So percentile is going to be below. The Z alpha, those are the ones that were to the right. Percentile are those the ones that are, so if you were on the SAT and you made better than 98 percentile, that's how many people you made better than. Those are the people that are below you. So percentile is all that's to the left. Z alpha is the ones that were to the right. So I want to know what is the percentile, I'm doing E, What is the percentile of 1475? So 1475. And I want to